Hello friends, so in the last session we have studied about the socket, the general introduction of the socket, along with we studied about the TCP stack, and also we'll studied about the system calls. So if you haven't seen that session, so please click on the link given in the description below. So in this session we will be starting with the types of the sockets. So there are three types of socket. So first one is a TCP socket, second is a UDP socket, and third is a raw socket. So what is a TCP socket? So TCP socket is a connection oriented protocol in which the client needs to be connected to the server before beginning any communication with the server. So what is a UDP socket? So UDP socket is used where we need connectionless communication, like we have a text message, we have the video streaming, so they all work on a UDP protocol. So we just have to fire a message and it will be received at the receiver end. So there is no connection that is been used in that. So that's why it's called as a connectionless communication. So it is not reliable also, but TCP is a reliable communication, because we need to first connect with the server to begin the communication, and there must be some heartbeat messages that is exchanged between the two, so that the connection will remain intact. So there is one more type of socket, that is a raw socket, is a special type of socket. So what it is? So raw socket is a type which pass the layer 2 ethernet packets directly to the application layer. So this raw socket actually bypass the TCP stack, so it can be used as a packet sniffing, like we have a Wireshark and TCP dump that use this type. So we'll study about this raw socket also. We'll have some practical demonstration in the coming videos. So let's try for next thing. So basic socket APIs. So we'll start with a basic introduction of the. So let's start with the TCP socket APIs. So the socket APIs is defined in sys socket.h. So the first API is socket. So it have three parameters. First is the domain, type, and protocol. So in the domain, we have various options, like we have AF underscore INET, that is for IPv4 type of data, AF underscore INET underscore 6 for IPv6, and AF underscore Unix for if we want to communicate between the two processes within the same system, then we can use AF underscore Unix in that domain option. Then we have the type. So in the type we have sock underscore stream if we want to create a TCP socket, and sock underscore dggram that if we want to create a UDP socket, and sock underscore raw if we want to create a raw socket. So in the protocol we need to fill 0, because it will automatically select the respective protocols depending on the type we are selecting from the second parameter for this socket API. So once this socket API becomes successful or greater than 0, then we will have this socket FD, that is a file descriptor that allows us to communicate between the two systems or a process. So this one is the first API. Next one is a bind. So it also have three parameters. So first one is a socket FD, which we get from a socket system call. Then we have the the structure socket. This is a kernel data structure that actually map your socket FD with a particular port and IP. And next is a length of the socket that will passing on, and on success it will return 0, and on failing it will return -1. So talking about this structure struct sock adder, so it's been defined in hash include inet in.h header file. So this is the sock header structure. So it have first the family. So family can be your domain, so af underscore inet for IPv4 and so on. And the next is a data. So we need to fill IP and port name here. So but there is one wrapper over there that we'll be using, and then typecast it to this sock header. So if you see here, the total size of the structure remains same with this. So we have this first we have to fill this sin underscore family with the domain. So we have af underscore inet for IPv4 or whatever. So whichever domain we are using in this socket API, we will use the same to fill this structure. Then the second one is the port. So whatever port we are listening on, that we need to fill here. Then the third one is the address. So what is the IP address? If you are using a local system, then we'll use 127.0.0.1, and if we are communicating or with another system, then we need to have that IP address here. And we also need to have network address translation, because this is a network socket. So okay, so let's go for our next system call. So the next system call is a listen system call. So they have only two parameters. So this AP actually system call is used for listening on a socket. So it's mostly used on a server program, but not on the client. So they have two inputs. First is a socket FT that we have created earlier, and next is a backlog. So this backlog is the concurrent requests that is coming, and we need to queue it up. If we put some value here, like 5 or something, so it will backlog that request from the client, which are coming concurrently, and then serve to the processing. And here we have the same success 0, and then we have fail -1. Then we have one more system call that is called accept. So this is I think one of the important API that we're using in a server program to set the connection to. So when the client send their request, it when hit to this accept call, it will create a new FT, and this new FT will communicate to a particular client. So there are the three parameters here also. So here the first is a socket FT that we have created for the server earlier. Then we have struct sock adder. So this sock adder is for client. Okay, so I have listed it here. So when the request come to this accept, it will save the client details to this socket, and next is a size of the socket. So if you have this accept, we return the new socket that will communicate with a particular client. So if we have 10 clients, then it will create 10 new sockets that will connect with that particular client. So it will initiate the three-way handshake with the client. So three-way handshake is used between the server and client for TCP connection only. So it is a sync and ACK communication to have a connection, and after that they can send or receive the data. So we'll get the client address, that is address and port in socket as structure. So we'll have the different value for this structure for each client. So we'll make use of a new socket to communicate with the client. So it's the same. So let's go for a next system call, the TCP communication. So this is a connect system call that is mostly used by the client to connect to the server. So they have the three parameters here. First is a sock FT. So the same sock that we have created from socket system call. Then we have the same server address. So here we need to fill the server address where we want to communicate. So it have port or and the IP also, and this is the size of the particular socket address structure. So connect is initiated by client to have a connection with a TCP server, So the connect initiate the three-way handshake. That will study it in a later session. What is three-way handshake? After connect client can talk with the server and exchange messages. So after connect, once you get connected to the server, then your connectivity is done, and now you can send or receive messages or exchange the messages with the server. So for exchanging the message of the server, there are few system calls also. So this is a receive system call. So this is used to receive the message from client or server. So it can be used in a client or server both also. So we have this first parameter of socket FT for the file descriptor where we want to receive or send the data, and then we have the buffer. So the message that is received by this call will be saved in this buffer, and then we have the size of the buffer, and then we have the flag. So here what is the return type? So we will get the number of bytes that is being received by this call as a return type. So if it is fail, then it is -1, and if it is success, then we have the number of bytes received here. So next system call is send. So if you want to send some message to the server or a client, so we'll use this send system call. They have four parameters either. So first one is a socket underscore FT. This is socket file descriptor. Then we have a buffer which we want to set to a client or a server depending on the requirement. Then we have the size of the buffer, and this is a flag. So it also returns the number of bytes sent, and on fail it will return -1. Then we have one more system call, that is close. So this close system call is for clearing the or deleting this FD from the memory. So we have a return type as 0 on success, and -1 for fail. So let's go forward. So this is a TCP server client API flow. So we'll be discussing the code in the next session, but here we'll see the the communication between the client and the server, and the list of APIs that is uses in server and the client. So this is a server and this is a client. We have some IP with a port listening onto this server. So we are listening to 8080 port on a particular IP for the server side, and we have one client on the same LAN, I think, because the IP is somewhat same. So it will communicate with this server. So the first the API or the system call that we're using on the server is a socket, and then we have the bind to bind to a particular IP and port. Then we have a listen, so that we can the server can listen to a particular port for the client requests. And then we have the accept. So on accept, it will create a new FD and communicate with this socket. And then we have read write, and then we have close. So on the client side, we need to use the same system call socket in here also on the client side, and then we use connect to have the three-way handshake with this accept, and then we'll have the read and write here and here also, so that the message can be communicated with each other, whether it is a client or a server. And next we'll have to close the socket so that we can have the clean exit through the process. So this is the overall flow, and the code related to this we'll study in the next part. So stay tuned, and goodbye.